Hi, welcome back. We're going to talk about chapter 9 this week. Okay, so chapter 9 is focused on water quality. Last week we saw um, a, a lecture about air pollution. Okay, so the last three chapters in your semester 9, 10, and 11 they are the application of environmental health. So far, from chapter 1 to 8, some of them we did not cover, chapter 8 and chapter 2, chapter 3, sorry. These are designed to develop your understanding about the basics of environmental health. Now, in chapter 9, 10, and 11, we're going to see the applications of environmental health. Out of that, chapter 10 was discussed in a previous video last week. This week is for chapter 9, water quality. Okay, as you know that water is very very important to sustain life, right? So we cannot live without water for more than a week. A person will die in the week. Okay, a person might live for a month without food, but without water, the person will definitely die. Okay, so what is the requirement of water? That's the first point that you need to know. First is that uh, average human needs around 2.5 liters of water per day for consumption. Okay, so that's around a little less than 1 gallon. That is coming from not just water, from food products that contains water, such as cucumber and some fruits and vegetables and things like that. Water from beverages. So, so all that is included in that 1 gallon calculation. Okay, so that's for consumption. What about the usage? So for overall use for an American adult is 100 gallons per day. Okay, so that includes uses for bathing and shower, toilet, and all that, cleaning dishes and all these things. Okay, so 100 gallons is an average use per day for an adult in US. Okay, what about the family? The family of four. I mean, the average use per household in the US is around 100,000 gallons per year. So the figure gets bigger and bigger, right? So so you can see that one family using 100,000 gallons per year. So it's a lot of water. Okay. So the water that is so this water we are getting from our tap. This is the tap water that we're talking about, right? So where we're getting this water, okay? How the water is being transported to you, and you have this luxury, and all of us, that you turn on the faucet and you enjoy the water. Okay. I mean this for the consumer it's pretty simple, but this arrangement is pretty wonderful. It's pretty innovative, and it's designed to have a very good accessibility to uh, drinking water, which must ensure that it meets the required standards to keep the environmental pathogens and chemicals at bay. Okay, this is what we're going to talk about. So, what is the journey of the water that we have in our environment, surface water, groundwater, and then how this machinery that we have developed to get the water from there, filter it, and ship to your houses. Okay, this is what we're going to talk about in chapter 9. So first of all, we need to know what are the water sources, where we are going to getting the water from. We are getting water from majority. I mean, there are only two sources. One is surface water, another is groundwater. Surface water is the water that you can see. Okay, so rivers and springs and ponds and things like that. Um, Groundwater, on the other hand, is not exposed, so it's underground, and there are underground reservoirs, tanks, whatever you call. They're in place, and the water bodies are underground and they're interconnected. It's sometimes it's a pretty big network. So that the underground water we get by building a wells, and then we extract the water from there. So that under that groundwater, that is groundwater. Okay. Um, Now, for surface water, we get from these different sources. Groundwater we get from the ground. So, which one is cleaner? The answer is groundwater is cleaner because it's not. First of all, it's not exposed as surface water. Surface water is exposed so that any vegetation and all this non-mineral contaminants can easily get into the water. So groundwater is not it's covered, and it's already percolated, and it's already filtered naturally by rocks and gravel and sand and things like that. So it's already pathogen free most of the time. So all you have to do is do some adjustments for the chemicals. So sometimes the pH could be higher or lower. Most likely the pH will be higher, so alkalinity will be higher. So it's a hard water. So that water needs to be softened up. So how we do that? So we remove the alkalis and minerals, and it should be fine. So that's adjustment that we have to do. So it requires basically very minimal treatment. Surface water, on the other hand, requires a very extensive treatment. Okay, we have to remove the pathogens. We have to adjust for the chemicals. May not The other part may not be as much, but the pathogen removal part is pretty big. We have to remove the solids to begin with. There are lots and lots of solids out there. So meaning the dirt and all that. So that is a difference between these two. Surface water requires a lot of treatment. There is another category that's in between surface water and groundwater, and that's called groundwater under direct influence of surface water. Okay, what is this? So sometimes the groundwater bodies are very near to the surface water body. So what happens is that surface water is, as I said, it's exposed, so we get a lot of dirt and all these things. And sometimes surface water is the bottom of surface water body is interconnected from the pores to the groundwater body. So that what happens is that then the pollution from surface water can transfer easily to the groundwater. So of course there is it's percolates and all that, but there is a chance that groundwater is under direct influence of surface water is not as cleaner as pure groundwater. So that's why it requires some more extensive treatment than the groundwater alone, but a little bit lesser rigorous treatment than the uh, pure surface water. Okay, so that's in between category. Okay, so that's about the sources. We have different type of stuff. Oh yeah, so another thing about the usage, you can see this pie chart. We see that 51% water is used for landscaping in the Southern California. So you can see that we have a very dry humidity here, very dry air here. So water content is pretty less. So a dry environment, so things get we have especially desert type conditions here. So we need a lot of water to keep up everything, to keep all the keep up agricultural and everything. So that's why irrigation a lot of irrigation is required to keep things moist. Otherwise, this land will become desert and agriculture will be lost. So we have to. So we need lots and lots of water. 50% of water supply goes to agriculture and irrigation alone. That's a big issue. I mean that's a big. It's a fact. For other parts of the U.S., the water is naturally in the ground, and humidity is high, and so they don't need to spend a lot of water for irrigation purposes. So humidity is pretty important. Okay, so now there are the sources. So we can talk about the dam and how the dams are built, and then there is a hydrological cycle that you need to know. Okay, so there is a transpiration, something called transpiration. So trees are important. Trees can hold the water, so that the desertification of land erosion doesn't happen. And trees can also perspirate oxygen, meaning they send out oxygen, and that oxygen interacts with the hydrogen in the environment, and that contributes to the clouds that contains water. So trees can bring the rain because of that. Okay, so having lots of trees is very important. And the figure, you can see there are different types of water sources. Seawater source, which is useless for us. It's salt water, we cannot use it. We have different types of reservoirs. One is called saturated, other called unsaturated reservoir. Saturated reservoir has a very fine and very hard boundary, mostly of the bedrock, a very granite, and a very hard rock to destroy. You need like a very heavy, high quality drill machine to do that. So that those are very like the water in those saturated reservoir is extremely clean. I mean, it doesn't require much treatment at all. There is an unsaturated where the borders are not as hard, as soft. Those are not as deeper underground, but they're a little bit less deeper, and they are saturated. They're unsaturated, so their rough borders are a little bit softer. That's the difference is that saturated reservoirs get filled up, refilled very fast. Unsaturated filled up a little bit at less speed because of the percolation, and the borders are very tough, and it takes time for water to percolate and get inside. But that is but because of that, the water quality is pretty high. But the refill rate is pretty slow when there are rainfall. Unsaturated water quality may not be as good, but the refill quality is pretty high. So most of the reservoirs in the U.S. that we have are unsaturated. There are saturated as well, but we have unsaturated, and unsaturated reservoirs, they fill up uh, pretty fast. So that brings up the point of non-renewable and renewable sources. Non-renewable sources are, you know, that we extract water from these sources. Then the sources have water depletion. Water is withdrawal, right, for the users, and then there is a risk that we will run out of water. But that doesn't happen because there is a rechanneling of these sources by rainfall. Okay, so in the areas where the withdrawal is greater than the rechanneling by uh, rain, which means rainfalls is unpredictable, not very sufficient. Those areas become dry very soon, and people have to look for other sources. In the Middle East, there are um, that it's a desert and everything. So millions of years back, it wasn't a desert, and there were um, it was like lush green pastures, and a lot of water was there. At that time, there was a good amount of rainfall and everything was there. It's exactly like other land areas with enough water and everything. So in that amount of time, lots of water was stored underground, and so they have the reservoirs were formed underground. And after that, there was a desertification, and the weather changed, and now it's all sand and desert. But still, underground, there is a lot of water, and people over there that are using that water. Unfortunately, there is rainfall is pretty scarce. So these reservoirs, underground reservoirs in the Middle East, they are not filled up, and the rainfall is pretty insignificant. So these are referred as non-renewable or fossil aquifers. Okay, so fossil aquifers is very important. They are not renewable. They are aquifers but not renewable, and so because of that, they have infinite life. They have their definite life. So after a few years, most of them will be empty because there is no rechannel source. Okay, so that is about renewable and non-renewable sources, and uh, uh, water dam. Yeah, we need to have a water dam. Sorry, water dams act as a source. Two act as a two important sources. They are designed to distribute water to distant communities. Okay, if we don't have water, if we don't have dams, we just use the river water. Then only like people in the nearby places they will be able to have that advantage of that water. But if you have dam, then you can build a dam on the river, so you can stop the river water on the river and build a giant wall. So what happens is that on the other side of the wall, on the other side of the wall is sorry, the same side as the river is, that side of the wall is going to be huge pool. Okay, that water is pooled, and so there is an artificial lake is created. And then what happens is that sorry no, so if this is a dam, this is a river, this is a river, and this is a river, this is a dam, and the river is flowing like this. And if you so the water will be stopped over here, right? So what's going to happen? It's going to be pool all around here. So and then we have and the water can the water level rise up, and they can flip. So to avoid that, they open a few windows, and the water flows in controllable fashion. So what happens is that this water has a lot of power, and the water, when it hits the foundation of the wall, near that foundation or near that place near the at the bottom, the generators are placed, the turbines. Because of the force of the water, the turbines move, and then they are hooked up with the electromagnetic field, and then the electricity is formed. So electricity generation is very important because of that. And also we can use that pooled water, that pool, and we can that's that now it's a lake is formed. And then we can hook up some pipes to these lakes, and then these pipes will carry water to all distant communities around that area. So a lot of so it increases the water coverage to a very great extent. So that's why dams are very important. Okay, so there are some things that we need to know is that uh, some of the things such as availability of water, fresh water. So you know that 70% of water is on the planet Earth, 70% is water, 30% is land. So, but that 70% water, most of that is useless because it's ocean water. Only 2.5% of water is fresh water. Okay, only 2.5%. So 97.5% is of the water that is available is ocean water. 2.5% is fresh water. Within that 2.5%, majority of that, which means that 1.5% of that water, so 1.5% of that water, so around like 70% of water of fresh water is inaccessible. Okay, it's stored in ice caps and glaciers, so we don't have any means to get that water. There are some great giant lakes are there in northern Canada and Siberia, but we do not have access to that because it's very cold environment, very harsh places. So 1.5 out of 2.5, 1.5% is, or 70% of fresh water is not accessible. 30% of fresh water is accessible, like which means like the 1% of that 2.5% is accessible. So you can see that 99% of water on planet Earth is either ocean water or not accessible. So 1% of water that we have, which we see, and that 1% contains groundwater and surface water both. Now, so you can see that how much water is important for us. There are two things that we need to discuss is something called water scarcity and water stress. Water scarcity is the availability of water is less than or equal to 1000 cubic meters per person, okay, for a country. Which is a water scarcity. In a perspective, we need to know what is a normal availability of water. For example, in Canada, the availability of water in Canada is 14,000 cubic meter per person. So you see, 14 times higher than water scarcity level. So if the country has only 1,000 cubic feet per person, which means that it's very limited amount of water, and they will have chronic shortages of water. They always have to worry about finding ways to give water to the citizens, so that because of that their development have issues. I mean, they have to uh, spend a lot of resources just to have this basic problem of water to be met. Okay, another one is called water stress. So water stress is basically the availability of water between 1,000 to 1,700 cubic meters per person. So it's a little bit higher, but still, I mean, it's still a lot lesser than the countries with the normal availability of water. These countries have a temporary water shortage problem. These countries are typically have monsoon weather patterns, or weather patterns where some months in the year are extremely dry, and some months in the year are extremely wet. So wet and dry cycles are there, such as Indian subcontinent weather, or East Asian weather. There are monsoon season, and the for out of a year, 3 to 4 months is extremely high, heavy rainfalls, rainfall that can bring floods. That amount of rainfall, but rest of the months are extremely dry. So that because of that, they have temporary water shortage. At least 3 4 months are dry, and they have a huge water shortage, but it's temporary. In my opinion, it can be easily solved if they built like giant tunnels to store the rainwater and then use it for the. But that's my thought. Okay, so water scarcity and water stress. Okay, then we have some other things that we need to know is point source pollution and non-point source pollution. Point source pollution is where if you have a leaking pipeline, then a dirt from or environmental contaminants from outside environment or dirt and things like that will get into the drinking water, and then water will be contaminated. How you fix it? You just repair the pipe and the problem will be solved. That's point source pollution. Non-point source pollution is like there are multiple entrances for the dirt to get in. Like the classic example is runoff, agriculture runoff, street runoff, water runoff. These type of things. The water is flowing through the street or agriculture field and taking all the impurities, all the chemicals, environmental pathogens, whatever with it, and then it finally the runoff meets to the stormwater pipes, and the stormwater pipes are connected to the drinking water processing plant, where or maybe a wastewater processing plant, not drinking water. Okay, so to remove those contaminants. So runoff. So that's a non-point source pollution. Uh, okay, so what we are left with is the final part is the treatment part. So we get the water from these different sources which I explained: groundwater sources or surface water sources, groundwater under direct influence of surface water, and there is a mechanism. So we have a giant pipes that are connected to these sources, and there are very huge pumps are there, and they pump the water from the water sources, and then take it to drinking water processing plant in Fresno, for example, in Fresno City. So in the drinking water processing plant, there are various stages where the water is cleaned. The first stage is where now this water is dirty, right? So it's not drinking quality water. what so we have to look at the content. 99% is liquid, so it's water, and there is impurity is only like 0.1%. It's not even 1%. 0.1% is impurity that includes solids. Now the solids are of different sizes: large solids, medium size, and very small solids. So the large solids, the first step is to bring the dispersed solids together. So they're like mostly medium sized particles. So bring the dispersed solids together, uh, and so that's the coagulation stage. So alum is a very good coagulant. So in the tank, when the water is brought to the drinking water processing plant, the first step is it's a coagulation. Alum is it goes through the alum tank, and there's alum inside it, and so that what happens is that the medium-sized particles, they forms clumps, and they come together and forms clumps, and then so what happens? Their weight increases, they become heavy. Okay, uh, and then the next step is called sedimentation, where the water is now sent to the next tank, where water is just sitting there in that tank, and there's a skimmer there, and then what happens is that the heavy particles, because of their weight, they float. They do not float, and then they drown, and they are deposited at the bottom of the tank. So a scraper is going to push the those solids at the bottom, and they're taken out and supernatant, so the liquid part is taken out for further processing. Okay, the next step is called filtration. So in the filtration, so far we have taken care of dispersed water particles, medium-sized particles, and large particles as well. Now what is remaining is the very small particles. So those are removed by filtration. So as we saw, in groundwater, it filters the percolates. The water percolates into the ground, and there are different layers: um, gravel, sand, and clay, and other things. Exactly the same phenomenon is used in the water treatment processing plant, where the filtration is for filtration we use different types of things such as water, the granules, gravel, sand, rocks, and things like that. And so water percolates through these different layers, and then all the small solid particles are trapped, and then the clear water comes out. Now the final stage is remaining is disinfectant. So from that, the water is sent for disinfection. Disinfectant, there are different types of disinfectants: chlorine, ozone disinfectant, and we have UV light. So all these disinfectants are processes are done, and then the water finally comes out of the drinking water processing plant, and by huge distribution networks, it's shipped to your houses. Okay, so that's how the treatment part is, and you need to know about this treatment part, and like it's very important. I'll ask an exam. Now there are some parts where you have to read about the waterborne pathogens. Okay, so there are cholera and enteropathogens, enteric bacteria, viruses, parasites, giardia. You can read about that, and that's important parts. Also, there are something called the disinfectant byproducts. So when the chlorine is a disinfectant that is used to deactivate the microbes in water, when it touches the water, there are disinfectant byproducts. Some chemicals are formed, and they are probably carcinogenous. And research has shown. So we have now decreasing the amount of chlorine, and we are giving more emphasis on other natural disinfectants such as UV light and ozone and things like that. So that's a disinfectant byproducts. It can cause different types of things. Even chlorine type disinfectants can cause different types of things such as premature abortions, and congenital problems and things like that. So we are working on that. The upcoming issue that is coming up is pharmaceutical products that are going in the drains from people's wastes, and then they're meeting to the drinking water, the well, water sources, and then drinking water. Um, we don't filter for those, but thing is that they are extremely diluted, and research is still ongoing with those pharmaceutical products can cause any problems and things like that. You can see that in the slide. But research is in progress. So overall, this is about the water quality. The the Forgive me because the slide was pretty long, but I wanted to touch all the important points. Remember that next week is our last chapter. That's chapter 11, food quality, food safety. And after that, there's a midterm three exam, and then the final, and then will be a final. Um, the due for the paper is the on Monday of the Thanksgiving, so 25th of November is the due of the paper, and I hope that you guys are doing well on the paper. If you have any problem, see me in person, or yeah, send me an email and things like that, and I'll help you out. Okay. And also to remember about the extra credit activity. I think I got received on like 10 responses, meaning only 10 people have some completed extra credit activity. If you want that benefit, please have complete that as you please. Thank you so much, and I think this video is done, and I will see you next week. Thank you. See you.